Hi there, and thanks so much for joining me on a talk about serverless components, one of the exciting projects we've been working on at Serverless to just make the developer experience around serverless development better. So without further ado, let's just get into it. This is me. For those who may watch a video later, my name is Gareth McCumsky. I'm a solutions architect at Serverless, the creators of the Serverless Framework, the most popular framework for building serverless applications, and have been building serverless applications since around 2016. And now I find myself in the position where I assist a lot of serverless developers by answering their questions and even sometimes helping design solutions for their problems. And now with components, we have another tool in the toolbox to consider. But I can start right off by saying the serverless framework is pretty great. It has provided a lot of developers the ability to build really great serverless applications. By allowing us to compose together the various managed services of the cloud providers in a relatively seamless way, and then just deploy that with a single command to the cloud. That's pretty nice and convenient. No more fussing with the AWS console. And whereas most infrastructure as code tools have been focused on the DevOps professional in assisting in putting infrastructure into the cloud that developers can eventually build around, the serverless framework is more about allowing the developer to build an application by choosing the managed services they need instead, with the oversight of those same DevOps teams. And with the ability to create serverless applications, we see all the benefits of serverless, such as pay per usage, not per hour, and a lot more. No more OS updates, application updates, load balancing, backups, and so on. But the serverless framework isn't perfect. Nothing is. There are some inherent issues that come from building serverless applications, and we have kind of just accepted them as the status quo. Things like the CloudFormation resource limit that has probably impacted most, if not all of us in this room, and is a problem I see on at least a weekly basis with someone asking for help as to how to get around it. And as a continuation of that, we are also beholden to how fast CloudFormation can deploy resources into AWS. And to be fair, this isn't CloudFormation's fault. This is a tool built in 2011 to assist DevOps teams to deploy infrastructure into AWS and maintain state. It wasn't designed for the highly iterative development processes that it is now used for. But some of the problems we see all the time is around local development, which is fraught with issues. And it's a problem because no matter how sophisticated you get in trying to execute your service locally, it will never be as accurate as actually testing in the cloud. It works on my machine. But then we run up against the issues of slow deployment speeds and so on. So while the best solution to develop locally is to not, and develop and test in the cloud, that developer experience isn't the greatest. The slow deployment speeds make the iteration loops feel really long and can break users out of the mental state they need to be to solve these problems efficiently. But it's also not just in the technical limitations. Serverless application development is a lot to learn. Building serverless applications, while cool and fun, is quite different to traditional development. No longer do you take a developed application or service you can entirely run on a framework and just push it into a server somewhere. The process of constructing these applications is, in a lot of ways, far more architectural than just code anymore. AWS and the other cloud providers, for example, have a lot of stuff. And while these managed services do reduce the amount of work you need to do in configuring, installing, and maintaining your own hand-built services, you still need to understand the performance characteristics of these services, their limits, their interactions, their APIs, and more. API Gateway allows 10,000 requests per second per endpoint and with an additional burst capacity of 5,000. Good metric to know if you are planning on driving large amounts of traffic to your application. But where do you learn that? How do you learn that? What else are you supposed to know? And all of this creates a barrier to entry for a lot of developers. If I can build applications using my Laravel or Flask framework and put it on a machine somewhere, and it fundamentally solves the same problem, why should I bother moving? For a lot of developers, the advantages of incurring that switching cost just aren't high enough, and they back out really quickly, usually because those benefits are not tangible. So we decided to try to find a solution to a lot of these problems, but in a different way. So we experimented. Our components beta was released in about the middle of last year as a way to get it out to developers and get some feedback, and the response we had was pretty positive. However, it wasn't where we wanted it to be, and we wanted it to be better. We had solved some of the problems I talked about earlier and improved on other things, but also added a couple of new ones to worry about. And this was primarily accomplished by taking CloudFormation out of the loop. Without CloudFormation, there were no 200 resource limits, and by replacing CloudFormation with the AWS SDK, we also got better deployment speeds. However, the single biggest problem created by that was that we no longer had central state management. State management now became a problem for developers to solve instead, and was a pretty big one to do. If I deploy a component from my local machine, I have state stored on my machine, but as soon as another developer deploys, they end up overwriting whatever I have done. So this was something we knew we had to correct. And while we had improved the deployment speed significantly, it wasn't quite there. Making all those network requests over a developer's own network connection to AWS and the inherent latencies and inefficiencies added a not insignificant toll to the deployment process. So we went back and started considering our architecture a bit further. And after some time, we got to a place we thought looked good, and we had our official release of components. In April of this year, incorporating our learning from the previous beta, and with some significant changes and improvements taken on board. One of the biggest changes we made was to actually move the deployment process that ran on a developer's machine, making a ton of network requests to AWS over their network, to the cloud. What this means is that when you run serverless deploy now, the only network traffic is uploading any code artifacts that are a part of your service and the configuration file, and all other activity happens within AWS itself. This resulted in a massively improved deployment speed because all requests to deploy into your AWS account are happening within AWS using their local networking infrastructure and their super fat dedicated fiber pipes. But this move had other advantages. In a single stroke, because deployments are now centralized, we can offer users state management as well. So the risk of multiple developers in a single team accidentally overwriting each other are gone. And this is all made possible because the platform I will be showing off today allows teams to create an organization under which they can associate their components deployment, and each organization has state managed for each component on the specific stage or environment they deploy to. Doing something like serverless deploy -- stage dev and having that actually be a shared development environment for teams was now a possibility again for components users. And to make all this happen, we had to have some kind of management platform that allowed teams to configure and manage their organization and the components they develop. And in a couple of minutes, we'll be looking at app.serverless.com ourselves and how that helps simplify the entire process. So I've been talking about the history of components, but what is a component? Hopefully the demo today will make things clear as well, but let me set a little context too so we don't go in blindly. Firstly, it's different to the serverless framework that you've used and loved since 2015. While the serverless framework allows us to compose and manage services into a single serverless service that is usually a specific microservice, components are meant to be ways to solve problems more concretely and with much less need for configuration. Think NPM modules for serverless. Some NPM modules are entire frameworks around which you can build other solutions, such as the serverless framework, React, Vue, and so on. And others are small building blocks that are used together with other building blocks. A component solves one specific use case and makes it possible for a components user to rapidly deploy that solution without necessarily understanding the underlying architecture of what is actually deployed into the cloud. It is also possible to combine multiple components together into a single deployable solution and have that components application itself be a component. And lastly, while right now components are focused on AWS, since the reality is that that is where the vast majority of the market is, we are currently working on adding additional capabilities to make components as cloud agnostic as possible. There is inherently nothing that makes a component exclusive to AWS even now. Okay, so that's enough context and history. Let's get into looking at what components are and actually playing with them. Now that the scripted part of the presentation is done, let's do a bit more of a live session demo where I'm going to show off a bit of how components are used, how you can even build your own basic component right now using the components core that we developed at Serverless. Yeah, and let's get started. As you can see on the screen right now, I am loaded into app.serverless.com. I'm currently on my organization that I created for the demo today, Serverless Days organization. And while you don't have to start here, if you want to start using components, this is a great way to get bootstrapped. It'll pre-configure a bunch of things for you. And to do so, I'm going to choose Create App here to go and select the component type that I want to use. And we're going to take a look at the Express.js component here. So selecting as Express.js, I'm going to click the Deploy button. This is going to give me something I can run in the terminal to initialize. I've already got the NPM, the module serverless installed, so I'm just going to grab this initialize token here. And then I'm going to go to my terminal and just run that command. And it's going to essentially pull the Express component down for me to start using it and building on it and pre-initialize it with some settings for me. So if I just take a look, I can see I've got my Express app here that I created. I could have changed the name when I initialized it, but let's just keep things simple. And I can now go ahead and open up my editor so we can start taking a look at what that looks like. So in my folder structure here, you can see I've got a serverless.yaml file. If you've used the serverless framework, this should be familiar, but the structure is probably going to be vastly different. And as you can see here, there's far less configuration that I need to do here. The first things you might notice is that I have my org specified. So this is how I can link my component to my org I created. And I have my app name as well specified, as well as a name that I can specify for my specific component that I'm going to deploy. In this case, this is entirely ready for me to actually deploy into the cloud right now. So I'm actually just going to open up a terminal here and do a serverless deploy and have that deploy into AWS for me. And this is using the credentials on my local machine right now to deploy into my AWS account. In the very near future, you'll be able to set up AWS connections within app.serverless.com and rather use your connection through that. And you should see that it'll be finished. There we go, 17 seconds. We now have an API endpoint deployed. And if you contrast that with the serverless framework itself, there is obviously an improvement here in this deployment speed. Now, this being the initial creation of this will take probably a bit longer. But right now, I have a full-blown Express application sitting in Lambda, and I also have my API gateway endpoint I can execute here. Let's go ahead and open that in the browser. And yeah, it's a very simple Express endpoint. So let's go make some changes to it. Why not? First of all, one of the things I'm going to do, and that's incorporated in the component's core, is the ability to switch on dev mode. So let's go ahead and do that. You run serverless dev. Give it a few seconds. It's initializing dev mode for me so that it can watch changes in my files and also automatically deploy them. And if I go to my app.js file, this is an Express application. Let me just make this a little bit easier to see. And you can see dev mode is watching right now. So let's go ahead and make a change. I'm just going to, let's log out the request. Why not? And I've saved that and it's deploying. And in a couple of seconds, that's going to be fully deployed. And I can then go execute this in the browser and I can watch the logs in my browser. So if I refresh the browser there, I'm now getting my logs pushed out instantly into my terminal here for me to work with. Let's make something a bit simpler. Here is my log. Save that. I'm going to redeploy that change. Give it a couple of seconds, and then I can go ahead and refresh here. And here's my log. So in this way, I am now in a very nice development mode that allows me to very quickly make changes to my API. I can go ahead and add additional routes, so I can copy this route out and make this the hello route and have this log out hello. Save that, and I can now go to /hello, and I should get a hello response in my browser. And there's my hello log there. And this is all built in as part of components. If I was building a component like this, the dev mode is part of component's core. I can just incorporate that into my actual component that I might be building. But there's more to it than this. App.serverless.com gives us access to more than just an organization that allows us to configure and combine our components together. I have some useful information here. So again, as part of a team of developers, I might have exposed endpoints that I need to make available to my team. And right away, I can give these to other developers in the team so they know how to access my Express API. But additional to that, built into the component's core, again, something that I don't need to configure or do any work on. You've seen me start this component from scratch already. I have metrics automatically built in. This is already bringing in useful data for me about API requests received, latencies involved, data processed, function invocations that have occurred, and so on. All of this information is built in as part of components. And again, if I'm building my own component, I can add these kind of settings in. I can push my own metrics at app.serverless.com. So my components have the required metrics that anybody using my component will want and need. Pretty compelling. And so this is the Express component. This is one of the easiest components to pick up and start developing. And we've already seen a large number of folks using this as a way to get into serverless because they have a knowledge of Express. They would normally go to the serverless framework and go through the rigmarole of using the serverless framework itself to set up Express and deploying into Lambda. And now they can just use this component. This component lets you just deploy that into the cloud nice and easily. But obviously, there's more to it than that. There are more applications that we could potentially use. So one of the next ones I want to demo is the full stack component, because this is a great demo of how you can, let's just make this the serverless days. Full stack app. Just to give it a unique name, why not? And then again, I can initialize my full stack service. I'm just going to drop to my terminal here. Oh, no, I'm in the wrong one. I need to go back. There we go. Let's create a new component. And again, these components are pre-built. I'm just consuming existing components to build my solutions. So when I have components available to me like this, if these are solving my problems, I can just use these immediately right now to do what I need to do. I don't need to go back to the drawing board and learn about S3 and Lambda and API Gateway and anything else. I can just consume the service and then start using them in the applications that I'm writing. And that's what's most compelling about components, is that folks can just consume them and build things really, really quickly. And there we go. Now I have my full stack app ready. And we can take a look at some of the files in here. But let's open up a editor so we can see what we're working with. And immediately, you might notice some differences. This is the root folder with no serverless.yaml within it, and 4 subfolders. And what this is, so the serverless full stack app, the full stack component, is a component made up of multiple other components. So instead of a single component, instead of just being one component configured unto itself, this combines 4 components together to create a component template. So here I have an API, I have a database, I have permissions that are required between my code and my API and the database and so on. And I have my site, which is going to be my static site built with whatever I like, whether that be React, Vue, Angular, you name it. I can then deploy a site into S3 with a CloudFront, in front of it. The interesting thing here is that there are dependencies between these. If you think about it, the API needs to know about the database, which is deployed independently. The API also needs to know about permissions, which are deployed independently. However, this is a fully functioning application right now that I could edit, but let's just run the deploy command to see what this gives us. And you'll notice the API will not be deployed until the database and permissions are deployed. First of all, we're deploying our database, which is going to be a DynamoDB table. And then we're going to be deploying probably either permissions or site, which is going to be, the site consists of S3 and CloudFront, as I said, and permissions is just IAM permissions. And that is the site being deployed. So now we're setting up some IAM permissions. There we go. And now the API will be lost. And what happens is that the component's core has a concept of outputs. So every single one of these has outputs that they produce. This API, this is essentially the Express service that we saw before. So here we can see there's a few more changes here, but we can see the API here is consuming the permissions that I was talking about, and it's consuming the database name and the indexes for the database. So how do we get that information? Well, the database component, when it was authored, has the capability to output data about itself, as well as the permissions. And if we go to app.serverless.com, and I give this a second to refresh, I can go and actually look at what those outputs are. So here is my full stack app. Database had some outputs, so let's go to the database configuration, and here are my outputs. When I deployed the database, it generated these outputs for me to consume. And the same thing happens with permissions. I can now consume what outputs I need for these permissions in order to incorporate them into other services. And at the same time, because my API was defined with the permissions in its own configuration here, when I ran the serverless deploy command in the parent folder of all these services, it automatically detected that there was no serverless.yaml in the current folder I was running the command from. It then looked into the child folders and saw 4 of them, each with their own serverless.yaml file, and noted that one of them had outputs relevant to the other services in the folder. So in this way, it was able to manage those dependencies, deploy the right things first, and not make a mistake and cause errors with deployment. Pretty useful way of composing these together. The only thing that I still need to do is to set up the site to point at the right API. I cannot add code to my site necessarily. So I've deployed this. I now have an API. So if I go to app.serverless.com, I'm going to go look at my API. It has an endpoint for me. So I'm going to grab this API gateway URL. Let's copy that. And if I go back to my site, I will find I've got a config.js file, and I want to add this here. Oh, I need to wrap that in quotes, obviously. Let's save that, and we will just run the deploy command again. And because of central state management, I'm not overwriting things. It is busy redeploying what needs to be redeployed. It's not going to redeploy everything from scratch. So this deployment is ultimately going to be that little bit quicker to complete. But now my site actually has a connection to the API correctly. Let's go ahead and open our site. I'm just going to copy this URL. Let's go back to the browser, open that. And here we go. This is the full stack app deployed this static site into S3, and it has a API and a database backend. I can register something else if I wanted to. Let's just make this Gareth at email.com and a new password. Not really bothered what it is, and there we go. And I can go take a look at the metrics that were created as well. So if I go back to my API, I can see here are some of the requests that were made, the API requests that were made. There was one API error that was obviously when I tried to register when I had already had an account, and so on. So I've got some nice metrics information. So here is my entire full stack application. Now I can go back, edit the code, change the static site, add my own API using dev mode again. Let's go ahead and take a look at what it looks like to actually create your own very basic component. How do you get a component created and spun up? And my serverless days component, let's create a new one. I'm just going to open up my editor in here. And so now, the first thing I need to do is to create a configuration file that's going to define the new component that I'm creating. So I'm going to add a new file, and I'm just going to call this file serverless.component.yaml. And within this file, I'm going to paste a very simple example that's going to have all the basic configuration I need. And I just go from the top and work my way down. So the name of my new component is going to be my serverless days component. My version, I'm going to call this dev. So I'm going to keep this as a dev mode. This is a special version that you can use on a component while doing development so that you don't need to keep incrementing the version key every time you publish it. The author here is going to be me. Obviously, you put yourself there. The org that I want to do this with, so I'm just going to go ahead and grab my org over here that I've created for this purpose and paste that in there. So this means that my component is now registered to my organization. And I want to point where my source code is going to be that's going to build my component. So the default here is to create a source folder, and I'm just going to continue to use that so I can keep my logic separated. And everything else here is optional. So I'm actually just going to remove the rest of this. And now we have our basic configuration done. Easy. Now I need to create the actual code that is going to generate my component that's going to make the AWS SDK calls. And for that, I go to my source folder, and I'm going to create a new file called serverless.js. And in here, I'm also going to create some very just add some basic code to get us started. And then obviously I'm going to change my component name to match what I want. And that's going to be my serverless days component. And I just exported the right one here as well. And for all intents and purposes, this is a fully functional component. It doesn't really do anything. But if I go ahead and save this file and do a SLS publish, this will now make my Bootstrap component available to other developers to use and consume. We'll take a look at what that looks like in a second. And to do that is actually remarkably simple. I can go back to my command line here. And now I want to use my component I've just created. It's not going to be available in app.serverless.com yet because this is my own application, my own component that I've generated. So let me go and use SLS init. And then I'm going to use my component name. Let me go to my component here, grab my component name up there, switch back, and then initialize that way. So now it's looking for this in the registry because I just published there. And this is what they see. They see a serverless.yaml file with some basic configuration. As you can see, the only things I need to add here will now be a name property because every component needs to have a name generated for it. So I'm going to call this Gareth's component instance. And I want to associate this with the org I've got. So let me go and grab the org here and paste that in. So now when I deploy, it's going to be associated to my organization. And I can now go ahead and just serverless deploy. And there's no other configuration needed. As the component author, I never required any other specific inputs to be needed for this component to work. Somebody can just have this very basic less than 4 lines of configuration, and the deployment will now execute. And if I go back to app.serverless.com, I can see there is my Gareth's component instance. It's automatically all incorporated in here. If I want more information about building components, really components at this point is really about just adding code into this deploy function. So And really the things to take note of here is this deploy function. This is the only required function when you're writing your own component. And here is where you will do things such as make calls to any SDK you need to provision infrastructure in the cloud. And you can do things like store state in using this .state and then whatever values you want. So database name is equal to, and then whatever name you got out of the configuration that you needed. You can, and if you want a more general guide as to how what components look like and how to build them, if you go to serverless /components, you can come through here and you can see there's documentation here on building components. And this is where I've been grabbing some of the code that I've been using to help demo building components. And this goes through a lot of the details, things like how to enable specific features, such as input and output types, which is a great way to manage required inputs and formats and so on, validation of your inputs and your outputs, as well as how to deal with metrics. So we can actually use send metrics to the dashboard, and there's information about that here as well, and a lot more. I mean, there's just too much to go through in detail. So right now, I think what we're going to end up doing is switching to the Q&A portion of the talk. And yeah, feel free to ask me any questions you have about components. And yeah, thank you very much.